go. So let's just go over the homework here for percent and proportion and answer any questions, and then we'll start knocking out those conversions. All right, if we want to find 18% of 56, take 56 and multiply it by 0.18. Let's see, which would be 56 times 0.18. Uh, 56 times 0.18. I'm getting 10.08. All right. So we can check, right? Let's see, if we have 10.08 to 56, we should get 0.18. 10.08 divided by 56 equals 0.18. So 10.08 is 18% of 56. Right? 0.18, that is 18%. All right, number 2, 36% of what number is 33.12? So we have some number, we're taking 36% of it, and we're getting 33.12. All right, so that would mean x is 33.12 over 0.36. Some of y'all might set these problems up differently, whatever makes the most sense to you. All right, this is 92. So we can check, right? If we take 92 and take 36% of it, we should be getting 33.12. So 92 times 0.36. Yeah, that's 33.12. Okay, what percent of 54 is 17? So we got 54 times the percentage is 17, right? Where x is 17 over 54. So we got 17 divided by 54 is 0.31 or 31%. We can check. What percent of 54? Well, if we take our 54 and multiply it by our 31%, I get 16.74, which is approximately 17. Should have probably kept some more decimals here. All right, 17 divided by 54. I should have written this 148. That way, I could have written this as 31.48%. That way, over here, when I check my work, I actually should get 17. Yeah, 17. Any questions so far?
Yes.
All right. So what is 12% of 26? It's 26 times 0.12. And you just 3.12. So let's check. 3.12, 26 gives us 0.12 or 12%. So number 5, would you rather use a 70% discount coupon or 40%, 20%? than 10% discount? Well, I'd rather use the 70%, right? I don't understand this question. Yeah, you want the biggest discount, right? Let's look at number 6 here. Yvette knows the names of 8% of the students at Northwest Vista. There's 15,435 students. How many students does she know by name? Well, here's the total. Take 8% of that, and we get 15,435 times 0.08, 1,234.8 students. We can check. She knows the names of this many students out of this many. 15. We should get 0.08. Let's see, 1, 2, 3, 4, 0.8 by 15.35. Yeah, I get 0.08 or 8%. All right, Mary has swim practice 20 out of 28 days in February. What percent of the month of February does Mary have swim practice? 20 out of 28 gives me 0.71429. They want it to the nearest tenth of a percent. So this would be 71.4%.
So wouldn't it be 72 then?
Well, the 2 doesn't round that up. They want it to the 10th of a percent. So that's the tens, the 10th place, right? Because this would be 71.429%. So rounding that to the 10th, we're rounding it to this location, right?
Oh, okay.
That's a 2. The 4 stays a 4. It doesn't go up to a 5. All right. If they want it to the hundredths, this would be 0.43. But right, the 9 would turn the 2 to a 3. All right. What is meant by a proportion? All right. Well, it's ratios. You have 2 ratios equal to one another. All right. How do you solve a proportion? Well, you set the rows equal to one another. If you know 3 out of the 4 items, you solve. Proportions. You might have, if you have similar triangles, right? Say this one and this one. They're the same triangle, right? But one's bigger than the other. So if I call this x1 and this y1 and this x2 and this y2, the ratio of x1 to x2 is going to be the same as the ratio of y1 to y2. So if you know 3 out of 4 of these, you can always solve for the 4th. All right, I don't think we need to review these here, 10 through 14. Y'all know how to solve these, right?
Yes, sir.
Okay. Let's work some of these word problems. Heidi walks at a rate of 4.5 miles per hour. At that rate, how far can she walk in 50 minutes? All right, this is a unit conversion, right? So here, 4.5 miles per hour. So what they're saying here is that's our unit. 4.5 miles is equivalent to 1 hour of time, right? That's our number one, the pure number one. So how far could she walk in 50 minutes? So we're going to convert this time to a distance. So we can multiply by a smart 1. So setting this up, we got to get rid of minutes. And here, I'm going to put this down here so we have more room. We got to get rid of minutes and turn it into miles. But here's our conversion, right? I don't know how many minutes are in a mile, but there is a relationship with hours, right? I do want to get rid of minutes, okay? And I can do hours. I know how many minutes are in an hour, right? I know there's 60 minutes per hour. So the minutes go away. So now I've converted things to hours. This tells me how to convert hours to miles. So I got to get rid of hours now in favor of miles. And according to what they said, this being the number one, we know 1 hour is equivalent to 4.5 miles. So now we have miles. All the other units I've canceled out. So we have 50 times 4.5 divided by 60 equals 3.75 miles. So that sounds reasonable. At 4.5 miles an hour, if she'd have walked for an hour, it would have been 4.5 miles. This is less than an hour. So it should be a little less than 4.5 miles. This is a little less than 4.5, so it sounds like a reasonable answer. Hold on a second.
We'll still have to use the, oh, never mind, because the 50 is going to be the dominator, right? Not the 60 on the.
All right, sorry, what was that?
Oh, nothing. I figured it out. Sorry.
All right. Let's take this. Shrink it, cram it up here. Okay, cat. Pestering me. All right, the real estate tax for a house valued at $150,000 is $1,575. So here's the price of a house, and there's the tax on it. At this rate, what is the value of a house for which the real estate tax is this much? All right, so there we have the price of a house and the tax on it. They're asking about the price of a house given that tax on it. Okay, so for part B, let's do the part B first. As a proportion, there's the tax on a house, here's the price on a house. And then there's the tax on a house. What's the price on the house? Does that make sense?
Yes.
Tax price. So if we were going to solve this, right, P would be multiply both sides by P. That'll put the P over here. And then divide both sides by that. So we'd have 2299.50. Move this. 1575. 150,000. Which would be 2299.5 times 1575 divided by 150,000. That ain't right. What did I do wrong here? This is upside down. There we go. All right, flip this. Yeah. So 2299.5 times 150,000 divided by 1575. $219,000. So each of these things has dollars in it, right? If I actually wrote my units like I'm supposed to, those dollars cancel and I'm left with dollars. You don't want to end up with like dollars squared, you know? You should always write your units. They guide your math problem, you know? So the price should be in dollars, not in dollars squared or dollars cubed.
I have a quick question.
Uh-huh.
Like, this is the way I did it. Couldn't you do like the 150,000 times the 2299.50 and then divide that by the 1575? Because I still got the 219,000 that you got.
Yeah, that's what we did. You multiply these two together and then divide by that.
Okay.
So it's cross multiplication then, right? Or cross multiply?
Yeah, I mean, you could take this and divide by that and then multiply by this. It doesn't matter what order you do that in. All right. So, yeah, the way you did it was fine. So let's see, this other way, set up as a percent and solve. Well, if we look at this, we're going to find the percent tax rate. We have 1575 to 150,000. Let's see, 1575 by 150,000. That's 0.0105, right? A 1.05% tax rate. So given that tax rate, we want the value of the other house, and they give us the taxes. So we got some price, and if we take that percent of it, we get that amount of tax. All right.
So will we multiply then or divide?
Divide. So we divide both sides by this. We have 2299.50, 0105, which is going to be 219,000. See this guy up here? I wrote that down, you know. First thing you can do, you know, I skipped some steps. You just flip-flop both sides, right? You know, I could have started it the other way. P over 2. I just took reciprocals of both sides. And then now we multiply both sides by this, right? So 2299.50, 2299.50. All right, we're multiplying. So that goes away, and we have P equals product. Those are the two numbers, basically what we had up here. So again, the other way was finding the percentage first, and then setting it up to find the price. Here's another unit conversion. Michael took 2.5 hours to drive 157.5 miles on the road. That's our unit right there. They're telling us 2.5 hours is the same thing as 157.5 miles. That's our number one, pure number one. If he continues at that same rate, how many hours will it take for him to drive a distance of 210 miles? So we need to convert this length into a time using this. So multiplying by a number one, we got to get rid of miles in favor of hours. We know 2.5 hours is the same as 157.5 miles. So that gives us 210 times 2.5 divided by 157.5. It's 3.3 hours, which would be 3 hours and 20 minutes. That's 3:20 here. Let's do a quiz. Let's see. Try. So I'm from 198, some of these investments. Try number 21 here. Oh, this is quiz number 25. Number 1. This one too. All right, this is 321. Let's take 15. So it'll be 336. Dang it. There we go. 2 rows. Yeah. All right, number 1. See, if your money grew to $12,000 when it was invested at a simple interest on an investment of $10,000 in 5 years, what is the rate of interest? So what they're telling us here is the principal is 10,000, right? And the amount you ended up with was 12,000 after 5 years. What is the interest rate? Okay. So they're saying simple interest, right? Simple interest. I equals PRT, right? So your amount is the principal plus your interest. Oops. And the interest is PRT. Let me make some room here. We haven't done many problems like this. And this we can rewrite. We could factor a P out and write it as 1 plus RT. So that's your simple interest. Okay. So what we have here is A equals P times 1 plus RT. Let's move this somewhere else. They want to know what R is. So if we rearrange this to get R, we have 1 plus RT equals A divided by P, dividing both sides by P, right? So if we subtract 1 from both sides, we get that. And now divide both sides by T. We have 1 over T, A over P minus 1, which in this case is 1/5, 12,000 over 10,000 minus 1. So let's see, 12,000 divided by 10,000 minus 1, which is 0.2. Now divide that by 5. We get 0.04, which is 4%. Okay, I'll review these all the different types of problems that you can get here in just a second. Do you have any questions about this one? How many of y'all got 4%? Nobody? All right, I figure a lot of y'all have problems setting up this problem. You're probably trying to use like this one or this one. Okay, so I'll do a quick review of the 3 different formulas. Basically, you have either that one or these two, and all of the interest problems. So I'll do a review of that again here in a minute. Check out number 2 here. How long would it take your brand new car to depreciate 40%? Assume that it depreciates at 15% a year, compounded continuously. All right, and they say if you lost 40%, what would A be? Okay, well, let's see. Let's think about this one. So you have some price, right? Whatever it is, it doesn't matter what your price is. They're saying the amount should be end up being 40% of your price. So I could write that as 0.4p. All right, no matter what the price is. See, when they say that's what that means right there. All right, they're saying it depreciates at 15% a year, compounded continuously. Compounding continuously, we use this formula here, right? So in this case, we fill in the blanks. Let's see, what are we looking for? We're looking for a time, right? How long would it take? So if we rearrange this thing to get t by itself, we divide both sides by p. Take the natural log of both sides. So that gives us RT equals the natural log of A over P. And now divide both sides by R. Oops. We have T is 1 over R natural log of A over P. Okay, and this works out A is 0.4p, right? So we have 0.4p over p. We never decided what p was, right? It doesn't matter what p is because look, it cancels right out of this fraction. And our r here is a negative 15%, right? R is a negative 0.15. So we have that, and the natural log of 0.4 when we plug those numbers in. So if we take 0.4, take the natural log of it, this here is a negative number. So when we divide it by a negative number, we end up with a positive number. I divide that by a 0.15, and I get 6.12. Again, this is time, so that's in years. All right, so these were a couple of difficult problems, right? That's why I wanted to do them as a quiz here. When things depreciate, all right, that means your at a percent, that means your rate is going to be a negative. All right. Again, they said it's depreciating 40% overall. That means that your amount is 40% of your price. Right? New car to depreciate 40%. Well, let's see. Did I do that right? If you lost 40%, this is actually wrong. It should be worth 60%, right? So if it's depreciated 40%, you're left with 60%. So I need to change this to 0.6. depreciating, to depreciate 40% isn't the same thing as to depreciating to 40%. So let me rework this. We got 0.6 natural log divided by 0.15. This is 3.41 years. So here's your different formulas. You have simple interest, okay? I equals PRT. That's where no matter how long the time is, 15 years, 1 year, 7 years, you collect interest once and you use that. So in this case, your amount is your principal plus your interest. So you replace interest with that. So that's your principal plus your interest. You can factor out the P. Okay. So that's your simple interest. Now, they might give you the amount. They might want you to solve for the principal or the rate or the time, right? You could rearrange this. If they ask for the principal, you'd rewrite it like that. Divide both sides by this guy, right? Or if they asked you, for the rate, you divide both sides by P, and then subtract 1 from both sides. All right, so from there, if they ask for the rate would be 1 over T over P minus 1. But if they ask for the time, you divide both sides by R. 1 over R times A over P minus 1. Right, this formula has 1, 2, 3, 4 variables in it. If you have 3 of those numbers, you can solve for the 4th. So you want to be able to take this guy and rearrange it to solve for any one of those variables. So the next one is compounding in times per year. Okay. So if they haven't said continuous, if you don't see the word continuous and they tell you they're compounding once a year, they might say once or quarterly or monthly, right? Once, N is 1, quarterly, N is 4, monthly, N is 12, etc. You use this one. Amount is P 1 plus R over N to the NT. Okay. So in this case, if they give you P, R, N, and T, you know the amount, but you want to be able to rearrange this guy, right? So what if they want the principal? Well, you divide both sides by this guy, right? And dividing is the same thing as having a negative exponent, right? That negative exponent's like dividing by this. So that's if you know the amount and they want to find out what the principal was. Or let's see. I don't think they'd ask you about the rate, not in these kinds of problems. I mean, but you could do it. Usually they do this though. Then you have the continuous compounding. All right, think about like bacteria growing, right? Or something like that. Anything that's like natural, right? The problem might not say continuous compounding, right? If they do say continuous, you use this, all right? Or if they're mentioning something that occurs naturally, like bacteria growing or like radioactive decay, it's understood that that would be continuous compounding of interest. All right. So what if they needed P instead of A? Well, you could rewrite this, dividing both sides by that. All right. You rewrite it like that. Or if it's decaying, the amount's going to be like that because your R is going to be negative. Okay. But anyhow, what if they, the amount and the initial principle, or the initial number of bacteria and the future number of bacteria, and they want to find the rate. In bacteria, they use K here instead of R, but it's the same thing. It's just the name of a variable. If you want to find R or T here, e to the RT, you divide by A. All right, no, not this upside down. A divided by P, right? Divide by P. Then take the natural log of both sides. All right, natural log of E2 that goes away. So if you want the rate, divide by the time. 1 over T, natural log of A over P. But if you want the time, you divide by the rate. So it's 1 over R, natural log of A over P. Okay, so you have your three main formulas. This guy, here, let me do it in. That one for simple interest. This is compounding interest n times a year. And here's your continuous. But each one, there's 4 variables, and you want to be able to rearrange it to solve for any one of them like that. Okay. Any questions about that? Y'all still with me? Is anybody there?
Yeah, I'm here.
I'm here.
All right, cool. All right, any questions about this quiz? All right, we're still going to be doing a lot of this stuff. We'll go over it quite a bit though. All right, let's see. Where were we? We're back here. Number 18 here. All right, in a wildlife study, 50 penguins are captured, tagged, and then returned. A few weeks later, in the same lake, I guess, or vicinity, 300 penguins are examined. Of those 300, 4 penguins have tags. Estimate the number of penguins in the area. So this is a classic proportion problem. So they catch 50 penguins are tagged out of the entire population, the whole population, right? They catch them and tag them. So that proportion has to be the same. They catch 300 and 4 of them are tagged. So there's 4 tagged out of 300. So 4 to 300 should be the same as 50 to the whole population. All right, so I can flip these over, multiply both sides by 50, and we get, let's see, 300 times 50 divided by 4, 3,750 penguins in the area. Does that make sense to y'all?
Yes, that does.
Kinda, right? All right, here's another proportion. 6 pounds of carrots yields 20 cups of goodies. Call that goodies. All right. How many pounds of carrots are needed to make 7 cups of goodies? Well, if 6 pounds makes 20 cups of goodies, then 7 cups makes how many pounds of goodies? All right, so again, just flip both sides, multiply both sides by 7. So we have 20 times 7 divided by 6. 23.3 pounds. That makes sense. 6 to 20, 7 to, since we're going from 6 to 7, 20 should go up a little bit too, right? So 23.3 makes sense, right? They're just trying to screw you up because they have carrots and carrots and carrots and carrots and everything. All right, number 20. The ratio of the weight of an object on Earth to the weight of the same object on Pluto is 100 to 3. So something on Pluto weighs, let's see, 100 to 3. So 100 pounds on Earth is 3 pounds on Pluto. It's because Pluto is much, much smaller, and so it doesn't have the same gravitational force, all right? Since it's so small, stuff isn't pulled towards the planet as hard. So what would have 100 pounds of force downwards on Earth would only have 3 pounds of force going downward on Pluto. So if an elephant weighs 15,400 pounds on Earth, how much would it weigh on Pluto? So Earth to Pluto, Earth to Pluto. Again, we flip both sides, do the reciprocal. You know, if I was smart, I'd have just wrote it this way in the first place. Now I multiply both sides by this. And what do we get? 3 times 1,504 divided by 100 is 462 pounds. All right. That's why a weight isn't the same thing as a mass in physics. Mass, it doesn't matter where you're at in the universe, the mass doesn't change. But the weight of something does, because it depends on the gravitational force exerted on that mass. All right, here's a similar problem. 170 pound person on Earth weighs 85 pounds on Mars. How much does our 15,400 pound elephant on Earth weigh on Mars? Right? It's the exact same thing, right? Do the reciprocal of both sides, multiply both sides by that. 85 times 15,400 divided by 170. All right, this would be 7,700 pounds. Right. Hold on a second. Pounds. So Mars isn't as big as Earth, right? Because stuff weighs less on Mars. That doesn't make sense. I thought Mars was bigger than Earth by a lot. I guess not. The red planet. All right, there are, see, 110 calories for 28.4 grams of Rice Krispie treats. 110 calories for 28.4 grams. How many calories would 42.6 grams have? All right, well, multiply both sides by 42.6 grams. Grams goes away. We're left with units of calories like we want. And we have 110 times 42.6 divided by 28.4, 165 calories. Let's see here. A blueprint is scaled to 1 inch equals 4 feet. All right. So we have lengths converted to lengths. So 1 inch is the same thing as 4 feet. That's our unit of conversion, right? All right. So find the length of a closet, which is drawn as 4 3/4 inches. We need to convert that to feet in the real world. Get rid of inches, end up with feet. 1 inch is 4 feet. So inches goes away. And we have 4 times 4.75, 19 feet. All right, we could also have done a proportion here, right? Instead of doing unit conversion, all right, we could have done 1 inch is to 4 feet as 4.75 inches is to x feet, right? We don't have to write the feet, it's built into the x. So in this case, you have x over 4.75 inches is 4 feet over 1 inch. Multiply both sides by this. Inches goes away, we're left with feet. We're left with 19 feet here. So you could do that as a unit conversion or as a proportion. Either way is fine.
Wait, I have a question about that. So you is 9 feet, right?
Come again?
But how can you multiply feet with inches? You said it was 19 feet, so you multiply 4.5 with 4. Oh, you took away the inches. I'm sorry, never mind.
Yeah, the inches
I'm a
cancel
little
out.
late.
That's all right. I'm moving pretty
Okay,
quick.
so that's why you multiply the cost, right?
Yeah, the
So you don't have
4.
to convert the feet.
No, it's not a typical like 1 inch equals 12 feet, right? They're talking about a blueprint. So you have this small blueprint where whatever 1 inch is, if that's 1 inch, that 1 inch on the map or blueprint represents 4 feet in the real world. So instead of doing like 1 inch
Oh,
equals,
okay.
or 12 inches equals a foot, we're not concerned with that, right? And we're concerned with what 1 inch is on the blueprint to what it means in the real world. Does that make sense?
Okay, I got it.
Yeah, it's
Yes,
kind
sir.
of confusing. They did that on purpose.
Thank you.
Sure. All right, yeah, 24 here. At a certain animal shelter, the ratio of puppies to adult dogs is 7-4. This week, there are a total of 55 dogs in the shelter. How many puppies are in the shelter this week? So what they're hoping you're going to do is do the ratio of puppies to adults. They want you to go like, oh, 7 puppies per 4 adult dogs. No, right? They're talking about a total here. So 7 plus 4 is 11, right? So the ratio of puppies to total would be 7 to 11, right? So 7 to 4 is puppies to adults. So puppies to total is 7 to 11. All right, and they say there's a total of 55 dogs in the shelter. So 7 to 11, 7 puppies to 11 total should be X puppies to 55 dogs total. Does that make sense? Why we're
Yes,
not
that
doing
is.
7 to 4, we have to do the ratio of 7 to 11, right? Puppies plus adults, it's 11 total. Hold on a second. What's up, Pops? In the middle of class. It's all right. What do you need? Some parsley out there? Bread? You need onion? All right, class. Any questions about this setup here? Why it's 7 to 11 and not 7 to 4? We got X is 7 over 11 times 55. 7 times 55 divided by 11 equals 35 puppies. This kind of makes sense, right? Ratio of puppies to adult dogs is 7 to 4. Well, is 35 to 55? That should be the same as 7 to 4, right? All right, 35 is 7 times 5. At 55 is 11 times 5. This is ratio of 7 to 11, right? So 35 puppies, 55 total, right? 55 minus 35 tells us there's 20 adults. All right, so 7 to 4, all right, let's see, 35 to 20 should be the same as 7 to 4, right? 35 is 7 times 5, 20 is 4 times 5. Does that make sense? You can always check your work. There's always a way to check your work. At least eyeball it and figure out if it roughly makes sense, you know? Like if we got 350 instead of 35, we should be able to figure out if we just think about the problem that we're way off, right? Number 25 here. A team of college administrators captured and tagged a group of 90 fraternity men and then returned them to the university campus. Later, a group of sorority women wishing to estimate the number of fraternity men on campus captured 245 men and found that 35 of them were tagged. How many frat men would they estimate were on this campus? This is exactly the penguin problem here, right? So out of all the fraternity men, 90 of them were captured and tagged, right? 90 out of the total population. And then later, the women got 245, 35 were tagged out of 245 that they caught. So tagged to total, tagged to total. All right, so X over 90, 245 to 35. Multiply both sides by 90. We get 245 times 90 divided by 35. 630 fraternity men. All right, if there are 95 male students for every 100 female students in Northwest Vista, to the nearest tenth of a percent, what percent of the students are female? Let's see. 95 male and 100 female is 195 total, right? 100 of them are female. 100 out of 195 is the ratio of female to the total, right? So 100 divided by 195, 0.51282, or 51.3%, right? 8 turns the 2 into a 3, which like sounds reasonable, right? About half, right? Again, this is just like the puppy problem. A lot of students would look at this and go, they just write numbers down. They do this, right? 95 to 100. So they'd be like, 95%, right? And they just box that in and not even think about it, all right? Clearly, there wouldn't be 95% female, right? It's going to be approximately half, all right? This is wrong, right? You got to get the total, male and female total, right? Is 195, female to total. Let's see, it's 10 past 4. Let's take a 10-minute break since this class is a long class. We'll come back at 4:22 and continue on. Let's see here. Let me see if I can find it. Add a file. Yeah, this one. Oops. So here's an extra credit. Extra credit. All right. I don't know if y'all remember, but I invented a problem. Assume 100 billion people have lived and died in the history of the earth, and assume everyone becomes a ghost after life. And then I go on to tell you, assume 75% of the surface of the earth is ocean, and all the ghosts reside on land. And I give you the radius of the earth and the area for the surface of the earth. And then I work the problem. Okay. What I want you to do is choose, should it be ghosts or zombies? All right, and then provide an illustration for the problem. So those of y'all that like art, like to draw or paint or whatever, just create your own illustration for this problem. And depending on which picture is the best, I'll decide on either ghost or zombies. And then I'm going to try to write this up nicely and pass it on to the administration and see if they'll put it in the packet that y'all are learning from for next semester. And I'll make sure that your name is attached. So I don't know, what do y'all think? Is that cool? Y'all still there?
I'm gonna try.
All right. You can submit your response in Canvas. I put just like the quizzes and exams, there's a spot there for extra credit. This will be extra credit number 1. And I'll replace your lowest quiz grade with the 100. Or Actually, I'll do an exam grade. Because y'all mostly get hundreds on the quizzes anyways, right? So submit something. If it's decent, you know, there's, you know, some decent effort in there. I'll replace your lowest exam grade with a 100. And I'll try to come up with more opportunities for extra credit throughout the semester for y'all. So, let's see. Yeah, I'll just leave this. This will be in the notes here. But you get the gist of it, right? If 100 billion people have lived and died, I'm trying to find out how many either ghosts or zombies there would be per acre on the planet today. All right, back to review here. Close that one.
Sir, do we have a date for the end of semester exam yet?
I haven't looked it up. I should do that later. I know there's a place to look it up on ACES or whatever. Yeah, I'll find out and let you know. We still got, you know, let's see, at least 2 or 3 weeks, right? Yeah, I should find out. Sorry, I have to do that.
And do we have school or class next week?
I don't know. Let's see if we can find out. Where would we look for that? Let's see. We would go to like probably ACES, right? ACES. Sign in. Let's see. Track your progress. Emergency. Self-serve. Technical support. Should be a calendar somewhere, right? Maybe it's under here. Campus career student training. Using college scheduler. Faculty. I think something like such a simple question, there would be like an easy place to find that. Concourse. Navigate. Here we go. Faculty resources, important semester information. Student guide. Twins. Smart drops, blah, blah, blah. Final grades. A bunch of boring stuff. Oh yeah, there's student surveys. Did y'all get emails for like a student survey thing?
Yeah, I did.
All right. It keeps harassing me because nobody's done it yet.
Oops.
That's all right. And survey. Ooh, important semester dates. I don't know. You'd think like a day off would be important enough to put in there, but I guess not. Nah. No, I'm assuming we have Thanksgiving off. You know what I mean? Let me go back. Yeah, I'm gonna have to spend a couple of hours to try to find the the calendar.
Sorry.
No, that's all right.
December, because I know for my other classes it's December 24th is when we're taking ours.
the 24th is when we have what, the last day or what?
Other classes for their final exam around that.
Jesus.
I thought final exams were like the week of like the 12th or something. So I think it's usually the week before Christmas.
Yeah, that's what I was thinking, but
Not the 24th, the 14th. Sorry.
14th.
Oh, around there. Because I know
Yeah,
I have it somewhere.
that makes sense. I'll have
Sorry about
to
that.
I'll have to talk to my bosses and see if they can, this is my first semester dealing with this website and all of this, so it was different back when I used to teach 10 years ago.
Should it be under your list?
I think if you actually go to like the school, like alamo.edu,
Yeah, you read my mind. Exactly, right here, alamo.edu, right? Because it would be the same across all of them, right?
right, and then if you just type in like final exam schedule or whatever, you should be able to find it.
All right, let's see. First, let's find the holidays, right? Oh, I'm trying, damn it. The website sucks. Search. Please fill out this field. Okay. Well, let me fill it out. Maybe I could just do a menu here. Academic calendar. Boom. Let's see here. Registration, payment deadlines. No, we want. This is fall.
Okay,
Right?
the one for my social college class is on the 3rd.
What's that?
For one of my classes, it's on the 3rd of December.
Yeah, I show this class December 3rd being the last class for math.
Oh wow. Okay.
Like December 9th is my last class, but for my Monday, Wednesday class. So I think it's like the first week of December.
I remember making a calendar in Canvas, but
Yeah, I just clicked on calendar on the side.
I can't find it anymore. Oh yeah, there it is. And wait, what is this month? This is November.
Mhm.
Oh. This class won't show up. I don't know. I can't figure it out in there either. Let's see. Semester dates. Classes begin. Payment deadlines. No, I don't know. I'll find out and send y'all an email.
Oh my gosh, I wouldn't even think that it would be this hard to find, right?
Yeah. I mean, it wouldn't be if I knew my way around, right? That's why I've been procrastinating. Academic registration calendars. Uh,
Are y'all
holidays.
sorry? I've only been like half listening. Are y'all trying to figure out if we had Thanksgiving off?
That and when the final is, you know. Um,
So
We don't
if
have
I
classes on
remember
Thanksgiving.
correctly from last semester, we had like the major holidays off.
right. I know we have
Okay,
I just don't
Thanksgiving
know how
off.
many days.
final exam is week 15. I found it in the syllabus, but it doesn't give me a date.
Okay. All right. So, all right. I'll get verification so I can figure it out for my other classes too, and send the emails out to everybody and update the syllabus. Because I need to be able to find this stuff quickly, you know. All right. So yeah, no class on Thanksgiving. All right. I'm wondering about the Tuesday before Thanksgiving though.
That's what I was wondering more so, not necessarily Thanksgiving, but the Tuesday.
All
Well, I
right.
definitely have class all that week except that day.
Except for
So
Thanksgiving.
yeah, because I have class Monday through Thursday, and Thursday is the only day I'm off.
I'll ask my friend.
Because I thought we got the whole week, but apparently not.
That's what I thought, but that's what I was asking. I don't know.
Yeah, my English teacher definitely has me scheduled for Monday and Wednesday, and so she said
All
we
right.
only have Thanksgiving off.
I'm gonna send a
Unfortunately.
message to my friend who teaches. He's taught at the Alamo colleges for 49 years, so I'm pretty sure he'll be able to answer me. So as soon as he hits me back up, I'll let you know what he says.
My
Thank you.
husband said that on his class, he has Monday classes, and his professor has said that he still has class during Thanksgiving week. So I don't know.
Monday and Wednesday.
His is just on a Monday, so I don't know if like just Monday has classes or what exactly.
I remember back when I was in school that we only had off the Thursday and the Friday. You know, they should give you the Wednesday. You know, I'll be right back. All right. Yeah, I'll find out. I'm sure he'll get back with me, unless he's teaching right now. Otherwise, I'll send you an email later this evening. All right, let's get back to our review here. We only got about 20 minutes left of class. All right, Grills R Us is attempting to stimulate business by offering a "we pay the tax." Oh, we got some chats going on. Hold on. Week 15. Yeah. Again, I'll let you know. I'll send you an email this evening and let you know exactly what days we have off and exactly when the final is. Because I got to set up the Zoom link for the final and places to upload your answers in Canvas anyways. So Grills R Us wants to offer a "we pay the tax" day. Their advertisement includes the statement, "Come buy a $400 barbecue pit without paying any sales tax." Even though it appears that the customer pays no tax, Grills R Us must still send a portion of the $400 to the appropriate taxing authority. Essentially, the $400 the customer pays includes the tax. Hence, the seller must calculate the actual before-tax price of the barbecue pit, which the price for which the item could have been sold, so that after an 8.25 tax is added on, the total would be $400. So they're looking for the price to sell it at, where when you add the tax, you get $400, right? So they're just ramping up the price, right, to include the tax, right? So what price do they have to sell it at? So when the tax is already included, you get $400. Does this make sense to y'all, the setup here? All right. 8.25% tax. Here's the price. Hold on, it's a little bit more complicated than that, right? We have the price plus the interest. Oh, let's try that again. The price plus the interest needs to be $400, right? Well, the interest here is the simple interest, right? Remember the simple interest? P plus I is P plus PRT, which is P times 1 plus RT. All right, that's our amount. All right. So in this case, we're looking for our amount is P times 1 plus RT. I don't like all this though. I like it just breaking it down. The price plus the interest needs to be 400 bucks, right? So we don't know what the price is. We could factor out the P. All right, we know what the rate is. Here the time, it's just one time, right? So we don't need T here. Right, the interest in this case is just price times the rate. T is 1. So they're saying this is 0.08. All right, so we have 1.08 times the price needs to be 400 bucks. All right, so our price here needs to be 400 divided by 1.08, which would be 400 divided by 1.08. It's $370.37. All right, so what was the question? So the actual before price tax of the barbecue pit is this much, right? Because once you add the tax in, it's $400. Okay, so what they're doing is they're just ringing this up so that the register, once it adds tax, gives us this 400 bucks. But they're telling the customer, oh, just pay us 400 bucks, and we're paying the tax, right? No, they're charging them the tax. They're just lying to them and telling them that they're paying the tax, right? So instead of charging them, they're still asking for the same amount, 400 bucks. All right. Does that make sense to y'all? This is a long paragraph.
Yes, sir.
All right. Yeah, the concept is pretty simple, but the paragraph is very long. All right. Rounding to the nearest cent. Yeah. $370.37. So we get number 28 here. Cindy sees a bag she wants for $32.99. If the bag is on sale for 30% off, how much of a discount will she receive? Well, the discount, 30% off, we have 32.99. 30% of that, right, which would be 32.99 times 0.3. $9.90. That's the discount she's getting. What will be the sale price? Well, you can either take $32.99 and subtract $9.90, right? 9.9, which is $23.09. Or you could say, okay, here's the original price. Since it's 30% off, we're only paying 70% of it. So we go 32.99 times 0.7, and we still get 23.09. Either way, you get the same amount. Good. 29 here. Manna wants to buy a TV for $12.50, but it's on sale for 10% off. The sales tax is 8.25%. How much tax will he have to be? Well, it would be the total cost of the TV. All right, well, the TV costs this much, but it's 10% off, right? So you're only paying 90% of that. So 12.50 times 0.9. So that's that much, right? So, but now we got to add tax, right? So the tax is this times 0.0825, right? Times 0.0825. That ain't right. 0.0825 times 1125. Yeah, that's right. 92.81. That's the tax. So the total is the 1125 plus the tax. All right, so plus 1125. 1,217.81. All right, so the amount here is the initial price, but we're taking 90% of that. All right, and we're adding to that the tax. So 90% of that times the 0.0825, which is equal to that. So, all right, we are off Thursday and Friday, like I thought.
Thank you for checking on that, sir.
Yeah, no problem.
That's Thanksgiving week, right?
Yeah, on Thanksgiving week.
Okay.
All right, Ginger gets a haircut that costs $35. She likes her haircut and wants to leave a 20% tip. How much tip will she leave? 35, 20% is 0.2. So 9.2 equals $7 tip. All right, that's the tip she'll leave. Total, right, it's going to be 35 and 7. She needs to leave $42, right? All right, the cost of Robert's tickets decreased as the season went on. They started at $45 and eventually sold for $23. What was the percent decrease to the nearest percent? The percent decrease. Well, started at 45, right? And it dropped to 23. So that would be what, $22 drop, right? So if it dropped $22 out of 45, but 22 divided by 45, we have a 48.89% drop. All right, so it's a little less than 50%, right? 45, half of 45 would be 22.50. So if it had dropped to 22.50, we'd have had a 50% drop. But it didn't drop quite that far. It's just less than 50%. So it makes sense. It would have 48.89%. Okay. Does that make sense? Why we had to subtract these? All right. One common mistake that people make, I've made it, is doing 23 out of 45, right? You get like a 51% drop, right? Which wouldn't be correct, right? You gotta look at, it went from 45 to 23, so it was a $22 drop. So you gotta have the 22 over 45. All right, when a proportion problem can be solved as a percent problem. I don't know, I think they always can. Sorry. Looks like there's a red wasp in my house. I'll kill it later. Mixture problems. Remember these? In the Mississippi River Delta, fresh water at 0% salinity mixes with salt water at 3.5% salinity. We got 1,000 gallons of river water. So its concentration is 0% salt. With 3,000 gallons of salt water. So the salt water is 3.5%. All right. How many gallons result? 4,000 gallons. And what is its salinity? Well, remember, V1, C1, some volume at its concentration plus another volume at its concentration gives you a new volume at the new concentration, right? And the new volume, V3, is just the sum of the other two volumes, right? So C3 here is all of this divided by this. I always try to work it out before I put the numbers in, solve for the variable, and then in the last step, plug the numbers in. V1 is 1,000 at 0%, and 3,000 at 3.5%, all divided by 4,000. This is 0, so we have 3,000 times a 3.5 divided by 4,000, which is 2.625%. We still got our percent thing. If you leave the percent symbol in there, your answer comes out with the percent, all right? But if you convert these, if I put a 0.035 in there instead of 3.5%, then I would have to do the conversion again, right? These are usually a lot simpler if you just leave the percentage and keep it in there, right? All right, it stayed, so I didn't have to do a conversion. All right, if I add a cup of creamer, half a cup, which is 20% butterfat, to 2 cups of coffee. The coffee has no butterfat in it. It's just coffee. How many cups result? Well, 2.5 be 2.5 cups. What is the percent butterfat of the mixture? So estimate our answer before we work the problem. Well, you got something that's 20% butterfat and something that's no percent butterfat. Mixing them together, the answer should be between 0 and 20, right? There's more at 0 than there is at 20%, right? In fact, there's 4 times as much coffee as there is creamer. So we should be, you know, I'd guess like, let's see, would it be closer to 20% or 0%? Half a cup at 20%, 2 cups. Well, if we get 2.5 cups now, and only a quarter, well, a fifth of it, 1/5 of this, right? The 0.5 cups, 0.5 is 1/5 of the total. And that 1/5 of it is 1/5 butterfat. So that'd be like a fifth of a fifth. So a fifth would be 20%. A fifth of 20% would be 4%. I'm guessing 4%, right? Right, 0.5 cups is, well, no, it's 1/5 of 2.5. And of that 1/5 of the total, it is only 1/5 butterfat. So a fifth of a fifth. 1/5 is 20%, and 1/5 of 20% is 4%. So I'm guessing 4%. Let's see what we got. V1, C1, V2, C2, V3, C3. So again, just like before, We're dividing both sides by V3. And that's what C3 is. So V1 is 0.5 at 20%. Oops. V2 is 2 cups at 0% butterfat. And we have a total of 2.5 cups, right? So we could, if you wanted to, you have cups, 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 right? This is just 0. Cups over cups, those units go away. We're left with percentage. All right, 20 times 0.5. That would be 10%, right? So my in the head analysis was not correct. 0.5 times 20%, 2 at 0% gives us 2.5. Oh, wait. No. 0.5 times 20. 0.5 times 20. And now divide by 2.5. Yeah, for percentage. So I was right, what I did in my head. 4%. I was forgetting to divide by 2.5. So does this make sense? You always use this formula. I know they didn't put it in the packet. I had to look it up. When I first started teaching, before class, the first class, I looked in the packet and I could not answer these problems, so help me. And I looked at multiple websites trying to figure out how to do it. And most of them had all these charts and they had all these steps, and none of it made any sense. And then I finally found this formula, which made sense to me. One volume at its concentration, you add it to a second volume at its concentration, and you get a new volume at its concentration. And you just find out your variables, plug them in, and solve. Get 35 here. A recipe for Irish coffee calls for 1/4 of a cup of Bailey's. So volume 1 is 0.25 cups, and it's at 12% alcohol. Volume 2 is 1.5 cups, and it has no alcohol on it. How much liquid is there total? Well, 1.5 plus 1 plus 2 point plus 0.25 is a 1.75 cups. And what is the concentration? Well, let's estimate it. Let's see. We have 0.25. That's 12%. If we look at the total, 1/4 of a cup would be for 1/7 of the total volume. And of that 1/7 of the total volume, 12% is alcohol. So I take a 1/7 and take basically 1/7 and then take 12% of that. And that's what C3 is going to be. So let's see what we get. This is going to be exactly the same formula from up here. We lay down our standard formula, divide both sides by V3, plug in our numbers. 0.25 at 12%, 1.5 at 0%, and then we got 1.75. That's 0. So that's our 1/7. 0.25 divided by 1.75. And then we multiply that by 0.12. And we get, hold on. Let's write that as 12%. 0.25 times 12 divided by 1.75. There we go, 1.71%. Which sounds about right. All right. The answer should be between 0 and 12%. It's going to be closer to 0 than 12 because there's much less volume 1 than there is of volume 2. If there was more volume 2, no, it'd still make it even less. All right. It's based on the total volume here. If we increase the volume 2, if we said it was 10 cups, our percentage would go down, right? It would get really much closer to 0 because you'd increase the total volume, right? If we increased volume 1, the percentage would get closer and closer to 12%, right? If you had 1,000 cups of volume 1, it would almost be exactly 12% because this 1.5 cups wouldn't make any difference. So we got time to do these two. Let's knock these out real quick. Two quarts of half and half, so it's at 10% butterfat, is mixed with some whole milk. We don't know how much, just some, but it's 3% fat. If there are 5 quarts in the mixture, all right, how many quarts of whole milk were used? Well, if there's a total of 5 and you have 2 of these, that means that we had to have 3 quarts. 2 plus 3 is 5. All right. What percentage of fat is in the mixture? So it's the exact same formula we had before. You know, this time they told you V3 instead of V2, but since you add them together, that should be obvious, right? V2 is 2 at 10%, 3 at 3%, divided by 5. So we have 20% plus 9%, that's 29% divided by 5. 29 divided by 5 is 5.8%, right in between 3% and 10%. Last one.
If we leave it as a fraction, would that be correct too, or do you want it to convert it to a decimal?
It doesn't matter. In this case, you probably want to convert it to a decimal, you know.
Okay.
Because that's how we've been doing it, but you know, it's correct is correct, you know what I mean? But it's easier to grade if everybody goes for that, you know. You don't see this very much, you know. It's more often you'd see that written down just by convention. So I like them both.
Okay.
Let's look at the last one here. 2 liters of milk. We have 2 liters at 3% is mixed with some 1%. If there are 5 liters in the mixture, how many liters of one? Is this the one we just did? No. Oh, the same numbers though. If you had 2 and you end up with 5, this one has to be 3, right? What is the concentration? I don't remember all of these problems being exactly the same. I remember having problems where, you know, you had to find V1 or C1 or V3, you know what I mean? Basically with this formula, as long as that formula and this formula, V2 plus V1, there's a 1, 2, 3, 4, 5, 6 different variables, right? and there's two equations. So if they give you 4 out of 6, you can solve for the other 2. All right. So in this case, they didn't tell us this, they didn't tell us that. We have 4 out of 6. You just do the substitution, right? But all these problems are the same. I'm disappointed. We got 2 at 3%, 3 at 1%. Gives us a total of 5. So 6 and 3 is 9 divided by 5, 1.8%. Isn't that the same number we just got? No, 5.8. Okay. 1.8 makes sense. It's right between 1 and 3%. Okay.
I have a question. Will we ever get a question stating that we had to figure out the volumes or the concentration?
I thought I remembered giving exam problems where we had them like that. I don't know. Maybe they show up later in like the chapter review. If they're in there, we'll get to them. But yeah, you can rearrange this equation any which way you want, right? If you needed to solve for C1, you could, right? You just take this guy, and so if they gave you the mixture concentration, but they wanted to know this concentration, you just subtract both sides.
Oh,
Right.
so we would do the opposite then, right?
Yeah, and then divide by that. Boom. You know, you can rearrange it any which way you want, you know. You might have to do substitution here, right? Like if they gave you all the concentrations, all 3 of the concentrations, and then they gave you V3, if they did not tell you V1 and V2, you could still solve it, right? Because using V1 and V2, you'd find out V3, right? So if you had this, and this, you could solve for V1 and V2, right?
Yes.
All right, because you know that they add to give you V3. So even though you don't know what they are, you can still do substitution, right? Y'all remember that from that very last section
Yes.
in the linear algebra, yeah. All right, let's end it for today. I need to give you an exam, don't I? Exam number 25. Let's do. So we just did that one and that one. So this one. I know these problems are hard, and I need you working on them. This one. All right, get these in by midnight, and I will see y'all Thursday, right? Yeah.